and disposal. In addition, the operation of wastewater treatment plants can require significant amounts of energy and resources, leading to greenhouse gas emissions and other environmental impacts. Therefore, there is a need to develop sustainable and responsible practices in the wastewater treatment industry that minimize the environmental impact and promote the reuse and recycling of wastewater. This can include measures such as the use of renewable energy sources, the reduction of waste and emissions, and the development of new technologies for wastewater reuse. One approach to addressing these challenges is the development of water reclamation and reuse systems that can recover and reuse treated wastewater. Reducing the need for freshwater resources and minimizing wastewater discharge. Water reclamation and reuse systems can include measures such as membrane filtration, reverse osmosis, and ultraviolet disinfection that can remove contaminants and pollutants from the wastewater to meet specific water quality standards for reuse. Another approach to addressing these challenges is the development of advanced wastewater treatment technologies that can improve the efficiency and effectiveness of the wastewater treatment process while minimizing its environmental impact. Advanced wastewater treatment technologies can include measures such as nutrient removal, membrane bioreactors, and anaerobic digestion that can remove nutrients, pathogens, and other contaminants from the wastewater, while generating energy and other valuable byproducts. Innovation and collaboration are critical components in the development of sustainable wastewater treatment technology, as they enable the development of new solutions and approaches, and the sharing of knowledge and expertise across different sectors and stakeholders. One area of innovation is the development of new technologies and processes that can improve the efficiency and effectiveness of the wastewater treatment process, while minimizing its environmental impact. This can include the development of advanced treatment technologies, such as membrane filtration, that can remove contaminants and pollutants from the wastewater, and the development of energy recovery systems, such as anaerobic digestion, that can generate renewable energy from wastewater. Another area of innovation is the development of water reclamation and reuse systems that can recover and reuse treated wastewater, reducing the need for freshwater resources and minimizing wastewater discharge. This can include the development of decentralized water treatment systems that can treat wastewater at the source and provide local water supply, and the development of innovative reuse applications, such as irrigation and industrial cooling. Collaboration is also critical in the development of sustainable wastewater treatment technology, as it enables the sharing of knowledge and expertise across different sectors and stakeholders. Collaboration can involve partnerships between industry, academia, and government, as well as engagement with communities and stakeholders. For example, public-private partnerships can facilitate collaboration and knowledge sharing across different sectors and stakeholders, and can help to address the challenges of financing and scaling up innovative wastewater treatment technologies. However, innovation and collaboration also face challenges, such as the need for investment and resources, and the need for coordination and alignment across different stakeholders and initiatives. Therefore, it is important to develop effective strategies and frameworks that can promote innovation and collaboration, and that can address these challenges. Policy and regulation play a critical role in promoting sustainable wastewater treatment technology by setting standards and frameworks that reflect societal values and needs. and that encourage innovation and responsible practices.